Good morning, everyone. Today's topic is subtracting radical expressions. So, we said before now that radical expressions contain radical symbol, and that's the symbol. Sometimes people call this um, square root, but that's not it, it's roots. So, this is roots, and as we said in the other class, that it can be the cube root. It can be the fourth root, fifth root, or even higher, depending on the superscript in front of the radical symbol. So if we have 3 here, then that's the cube root. So yeah, we can say cube root of 64, you know, or you can say fourth root of 625, depending on whatever they are asking you. So, and in our case today, we'll be subtracting two radicals. So an example of the question we're given here, example 1, is we should subtract 7 root 3 minus 6 root 3. So what is important is the radicand. The radicand is the number under the radical symbol itself. So we have a radicand to be 3 here. So first of all, before you can do anything, you want to make sure the radicand are similar. They have the same radicand. That's like this is root 3, root 3. So if one of them is root 6 and one is root 3, you cannot solve it directly. You need to try to convert both radicand to similar radicand if it's possible. But if it's not possible, then that means you cannot solve the problem much more than that. You just have to leave it as whatever it is. So in this case, we have similar radicand, which is root 3, root 3. So with this, we can solve. So to solve this, all we just need to do is to subtract the whole number from the first whole number from the second whole number. That's the 7 from the 6, which is 1. So that's 1 root 3. That's what we have. So 1 times root 3 is, you can write it as just root 3. So that's an example. That is quite straightforward. Now let's look at another example here. Example 2. It says minus 8 root 10 minus 9 root 90. So we can see here that the radicand are not the same. When we look here, the radicand are not the same. You have 10 and you have 90. So we need to try to uh, simplify each of these expression, the whole expression. We need to try to simplify these expressions, each 1 and 2, to such a level where we can have similar radicand. Then we can now subtract. But if we cannot convert the radicand to similar radicand, then we just have to leave the expression as it's the way it is. And that's not solvable. But here, so let's see how do we do that. So to solve this question, let me just go down a bit. Yeah. So 1, let's first convert. You look at the radicand with a bigger number, which is root 90. So you first bring out the root 90. So this root 90, we want to break it down. We want to rewrite it. So to simplify root 90, what we just need to do is we use our division method, which is we write 90 here. We now think of what number can we use to divide 90. After 1 will go in 90 times. So then we move to the next number, which is 2. Will 2 go in 90? Yes. How many times? 2 divided by 90 is 45. Will 2 go in 45? No. Will 3 go in 45? We now move to the next number, 3. Will 3 go in 45? Yes. So 3 in 45, that's 15. Will 3 go in 15? Yes. So 3 in 15, 5. Will 3 go in 5? No. Will 4 go in 5? No. Will 5 go in 5? Yes. So that would be 1. So let's rewrite what we have here. So what we have is telling us that root 2 multiplied by root 3 multiplied by root 3 multiplied by root 5 equals root 90. That's what it's saying. So here, root 3 and root 3, when you multiply root 3 and root 3 together, that will give you 3. And when we multiply, and when we multiply root 2 and root 5 together, that will give us root 10. So that means what we are saying is that root 90 can be rewritten. So root 90 is the same thing as 3 root 10. Okay, now I'll write the equation here because, so our equation, the question they asked, initial question was minus 8 root 10 minus 9 root 90. So this was the question. So now we know our root 90 to be 3 root 10. So we can plug that in here. So let's rewrite this equation. Minus 8 root 10 minus 9 into bracket 3 root 10. So we can expand this out by saying minus 9 times 3, which is minus 27. Then we put our root 10. So we can see that we've converted our root 90 up here. We've converted it to 3 root 10. And when we put that in, we now have 27 minus 27 root 10, which is this. And you can see we now have similar radicand. So with this, we can solve it further. So here we just need to subtract the whole numbers and not the radical numbers. So the whole numbers, which is minus 8 minus 27. So minus 8 minus 27, that's minus 35. So the answer is going to be minus 35 root 10. So that's the way to solve that. So example 3 says 6 root 8 minus 5 root 2. So first thing is to check the radicand. Radicand here is 8, radicand here is 2. So they are not similar. We need to convert them to similar radicand. So we always solve the radicand with higher number first. We try to simplify that and see if we can convert it. So so root 8. So when we write 8 here, what will go in 8 after 1? 2 will go. 2 in 8, 4. So what will 2 go again in 4? Yes, 2 in 4, 2. Then will 2 go again? Yeah, 2 in 2, 1. So that's it. So what we have is root 2 multiplied by root 2 multiplied by root 2 is giving us root 8. So but don't forget, root 2 multiplied by root 2 is 2. So root 8 means that we can write it as 2 root 2. So that's root 8. So we can now plug that into our equation. So our equation says, that's our initial equation up here, says 6, then root 8. We put that right. Root 8 is now 2 root 2. So 2 root 2 minus 5 root 2. So 6 times 2 is 12 root 2 minus 5 root 2. So we have similar radicand here, and then we can just subtract our whole numbers, which is 12. That's the whole numbers is the one in front of the radical. So 12 minus 5 is 7 root 2. So that is our answer. Thank you for watching this class. If you like it, please do subscribe to my channel. Thank you.